Hey everyone, Mr. Voikin here, and lesson 6, the last one in unit 8. And we're starting off with a review of transformations, and it tells us that this is something that you learned earlier in another course like grade 8 or 9. So it's telling us to translate and to rotate some points. So translation means to basically move it right or left and move it up and down from its original position. So that one's quite easy. If we look at point A, its original position was at 2, 5. So 1, 2 in the X and 5 in the Y. So if that is point A, and if I was to translate by moving 3 right and 2 up, I'd basically go 1, 2, 3, and then go 1, 2, and that would be the new position of my point right here after it has been translated to the right 3 times and up 2 times. Okay, so that should be fairly simple. However, the rotations can be a little bit tricky for students. Let me just write the points down for this one right here. It's going to be over at 5 and 7. Those are the new points for point B. So if we look here, this is point A. By rotating it, we're putting it at point B. Now to move it to point C, we're saying take it and rotate it 90 degrees clockwise. So you got to think about which way does a clock work. Well, if we're starting up here at 12 and moving to 3, 6, and 9, the rotation is in that direction. That's clockwise. And the other way would be counterclockwise. Okay, so this is going to be counterclockwise, and this one will be clockwise. So it says to rotate, in part B, rotate 90 degrees clockwise. So if I was to draw like a line from the origin, and that's where it's rotating about is the origin, from there to point A, and then if I was to rotate 90 degrees, keeping that same length of a line, it should end up right here. Okay, now I'm just going to keep that line at that point, and essentially what we're doing is making a 90-degree line off of here, going to that point. So this right here is going to be my point C, and it's going to have coordinates of 5 and -2. Now you can see right here that basically what has happened is the original X became the Y and turned negative, and the original Y became the X and kept its original sign. Okay, and that will form a 90-degree angle right there. The next one says let's take point A and rotate that counterclockwise about the origin. Now remember, the origin is right here at 0, 0. So if I was to rotate that 90 degrees, again, we're going to sort of want to take our original line that was, sorry, that's really bad. The original line that's straight up between the origin and point A, and we're going to want to rotate it from that point all the way sort of down to there, and that's going to form point D, and it's got the coordinates of -5 and 2. Okay, and that is going to form a 90-degree angle right there. So again, what happened here when we rotate 90 degrees counterclockwise, we're going to take the original X and we're going to make it the Y and keep the original sign, and we're going to take the original Y and make it the new X but change the signs. These are just rules that you need to practice and go over several times in order to get this theory and understanding down pat. Okay, new investigation, perpendicular lines. So hopefully you know that a perpendicular line is a line that forms a 90-degree angle. So in this case, if I had A, B, and C, D, I could say that line AB is perpendicular to line CD. We're going to start off again with a point at 5 and 2. So it's starting out right there. And it's coming from the origin. So it says to draw a line to the origin, which is right there. So this is our line segment right there. Just going to do that with a thicker line so it shows up a little bit more. Okay, and next it says rotate the line through an angle of 90 degrees clockwise. So first of all, indicate that clockwise is going in that direction. And about the origin, so 90 degrees. So essentially, we need to rotate this thing down and remember the rules. So if it was at 5 and 2, it's going to be at 2 and -5. That'll be our new point between these two right here, forming a 90-degree corner. Okay, and it says find the slope of the two lines. Okay, so basically, I'm going to, instead of using the formula in this case, I'm just going to use our 2 points. So remember that slope. So I'm going to call this first one point, we'll call this O for origin. That would be point A, and we'll call this one point B down here. Okay, so going from the slope of OA is going to equal rise over run. So because we're on a grid and there's not too many lines, it's easy to count this. So first of all, I'm going up. How far did I go up? Well, 2 units. And how far to the right did I go? 1, 2, 3, 4, 5. So this one has a slope, a rise of 2, and to the right 5. Going up is positive, going to the right is positive. So that is just going to be a slope of 2 over 5. Now what about going from the slope of OB? Again, that's going to be rise over run. And that's going to equal, well, again, coming from the origin, I'm going to have to go down to get to this point. So 1, 2, 3, 4, 5 down, and then 1, 2 to the right. So if I was to write this out, the rise was down 5, so it would be -5, and to the right is positive, so +2, and so our slope would be a -5 over 2 because it can't be reduced down anymore. So what do we notice about these two right here? I guess it's going to say make a conjecture. Part C, make a conjecture about the slopes of parallel line segments. Well, what are we going to do? We're going to, if we look at this one, our first one, it was 2 over 5, and the other one became a -5 over 2. So when we have a perpendicular line, we're going to invert the fraction and change the sign. Okay, so basically that means if I had a slope of -1 over 3, the perpendicular slope would be 3 over 1, and it would be positive if the original one was negative. Okay, so if we just look at this review right here on parallel and perpendicular lines, it says if the two lines are parallel or more than two lines, they will have the same slope. So for example, M1 will equal M2. If the lines are perpendicular, that means forming 90 degrees. The product, so that means multiplying the two slopes together, would be -1. So if you think back to our example where I said if we had a slope of -3 over 1, the perpendicular slope would be 1 over 3. We want to find the product of that, so we multiply it together, and it should equal -1. -3 times 1 is -3. 1 times 3 is 3. -3 over 3 is -1. You are correct. Nice job. So it says right here on this line that for perpendicular lines, like I said, just flip the fraction and change the sign. Each slope is the negative reciprocal, so that's a fancy way of saying that. The negative reciprocal. So reciprocal means flipping it, and negative means multiply it by -1. So if it was negative, it becomes positive. If it was positive, it becomes negative. Now this is provided that the slope is not equal to 0. Okay, because you cannot have following the rules. If I've got a slope of 0, which is a horizontal line, I cannot really say that this would follow the rule, because remember, this one has a slope of 0 and that is undefined. So in this case, it doesn't follow that rule. Because if this was a 6 over 0 and we flip that up and down, make it negative, again, this part is not possible. Okay, let's move to class example number 1. It says we have a line segment that we're calling AC. And it's got a slope, a positive slope of 3 over 4. So that means it's going to be going from left to right. It's going to go upwards, and it's going to move up 3, right 4, up 3, right 4. And remember, like I said in the past, that would be the same as down 3 and left 4. Okay, so write the slope of line segment GH that is parallel to it. Well, that would be the same thing. 3 over 4, because parallel means the slopes are the same. So the slope of GH equals 3 over 4. Write the slope of BF if it's perpendicular. So the slope of BF would equal, well, again, flip that fraction and change the sign. Okay, class example 2 is saying we've got two slopes. Determine if they are parallel, perpendicular, or neither. So this should be fairly simple. The only thing, notice that M1 in this case is reduced down as far as you go to 1 over 4, but M2 is not reduced down, because 3 over 12 can be reduced down. I can divide 3 into this, and I can divide 3 into that, giving us 1 over 4. Now in this case, they're both positive, they're both the same, so this would be a parallel line. And for the next one, M1 is 5 over 7. Let's just make that green to keep it in suit. Whoa, whoa, whoa. M1 is 5 over 7, thank you. And M2 is going to be 14 over 10. Basically, I can see that I can divide 2 into here, I can divide 2 into here. So if I take 14 divided by 2, I get 7, and 10 divided by 2 is 5. So the original one was 5 over 7, and the new one that we converted, or M2, is 7 over 5. Now in this case it would be neither, and the reason is because although the fraction is being inverted, so it is the reciprocal, but it isn't negative. If it was going to be perpendicular, then this one would have to be negative. Okay, here in class example 3, it says we have 2 points forming a line segment PQ, and P is at 4, 7, so I'm just going to label those as X and Y1, and this can be X and Y2. The slope of that line is going to be Y2 minus Y1 over X2 minus X1. Negative 2 minus 7 is negative 9. 6 minus 4 is going to be 2. So can this be reduced down? No. The slope of that line is negative 9 over 2. Now in part A right here, it's saying if I have another line segment that's parallel to PQ, what would its slope be? Well, it would be the same, negative 9 over 2. And part B is saying, what if I had a line that was perpendicular to that? Well, again, I would just invert that fraction. So this would be m equals 2 over 9. The original one was negative, so the new one would be positive. So that's our final answer. And here we go on class example 4, and it looks like we only got 2 more. 4 and 5, so this time we're forming a triangle with points L, M, and N with those given coordinates, and we need to prove that it is a right angle triangle. So the first thing I would do is draw this thing out to find out which points are which. Okay, and if we look at point L, it's going negative 4 in the X and positive 2 in the Y, getting us a point L right here. And I'll just write down the points. It's negative 4 and 2. Now, whenever you're transferring points, just double check to make sure you've done that right. You know, even label if you want to. That's your X, Y, X, Y, X, Y, just so you're not making a mistake. That's our X and that's our Y. Negative 4, 2, negative 4, 2. We're all good. Because if you copy it down wrong, all your calculations are going to be wrong. Point M is negative 2 in the X, so it's going to the left, and positive 7. So 1, 2, 3, 4, 5, 6, 7. So it's going to be somewhere up here, and that's going to be point M, and the coordinates are negative 2 and 7. And the last one is point N, which is at 1 in the X and 0 in the Y. So that is going to be this point right there, which is going to be point N at 1 and 0. Okay, and that's going to be forming a triangle. So if I draw a line between M and L and form a line between L and N, and form another line between M and N. Hopefully that's making a right angle triangle. So basically, what do I have to do to make sure it's a right angle triangle? Well, I want to compare the slope of LM, and I want to make sure that it is perpendicular to the slope of LN. So the slope of LM is going to equal, so again, I'm going to label some points here. So if I go X, which one are we doing? M, X, Y, 1, 1, X, Y, 2, 2. So in this case, it's going to be Y2, which is 7, minus Y1, which is 2, over X2, which is negative 2, minus negative 4, which becomes a plus 4. 7 minus 2 is 5. Negative 2 plus 4 is 2. So the slope is going to be 5 over 2. And that can't be reduced down anymore. So that is finished. So if I think a little bit ahead, if it's going to be perpendicular, that means the new slope would have to be a negative 2 over 5. So let's do that math. The slope of LN is going to, now I'll just have to relabel this one. I've already labeled L as 1s, so I'll label this one as 2s. and it's going to be y2 minus y1 over x2 minus x1. Two negatives are going to make a positive, and if I do the math here, 0 minus 2 is negative 2, and 1 plus 4 is 5, and when I compare these two, they're the same, and when I compare these two right here, I can see that it's the negative reciprocal of each other, so these are perpendicular, so that is a right angle triangle. It is true. All right, the last one, class example 5. So it says that we have two lines that have slopes, and it gives us the slope of this first one. It says it is a negative 3 over 4, and the other slope is k over 5. So we just don't know what that value k is, and the question there, what they're posing to us is find that value of k. So it says, what will k be when it's parallel, and what will k be like when it is perpendicular? All right, so for the parallel one, just remember your theory that if you have a slope of negative 3 over 4, the other slope is going to be the same. So I just make it the same by saying it equals the 3 over 4, and I would just put a k right there and a 5 right there. Now basically what I've got is two ratios that are equal to each other, and I just have to use cross multiplication to solve for this. So k times 4 is 4k, and negative 3 times 5 equals negative 15. To solve for this, I'm going to divide both sides by 4, and in this case k equals negative 15 divided by 4. Now because 4 cannot divide into 15 evenly, that would be our answer right there. K is equal to negative 15 over 4. Now what about for the perpendicular one? Okay, well I know that negative 3 over 4, if I now multiply it by k over 5, what do I know that equals? Well, I know that equals negative 1. If we think back to somewhere over here where it was saying that, right here, if you take two perpendicular slopes, multiply them together, the product will be negative 1. So I'm going to take the original slope, negative 3 over 4, multiply it by k over 5, and that's going to equal negative 1. So basically when we multiply the left side here, you're going to get negative 3k over 20, and that's going to be equal to negative 1. Now because I have a fraction right here, this denominator of 20, I need to get rid of that in order to solve for k. So I'm going to multiply everything in here by 20. And when I multiply 20 by this first term right here on the left side of the equal sign, it's going to be 20 times negative 3 divided by 20. Basically, it just cancels out the 20, and you're left with a negative 3k equals, well, because I multiplied the left side by 20, I also need to multiply the right side by 20. Negative 1 times 20 is going to be negative 20. So again, now we're just down to simple math or algebra. So I'm just going to multiply both sides by negative 3, which is going to cancel those negative 3's, and leaving me with k equals negative 20 over negative 3. And because they are both negative, really we would simplify that to 20 over 3. And 3 cannot divide into 20 evenly, so in this case, the value of k for the perpendicular line would be an exact value of 20 over 3. Okay, that's it. So the assignment starts on this page, which is 540, and goes all the way down to looks like 545, and then the answers are on that page as well.